Now, looking at the title of example 7, when it says sometimes none of the rules seem to apply, sort of suggests that you're probably going to take a different path. And sometimes that can be frustrating because you see the tangent squared there in the denominator and you think, well, what if I converted that to a Pythagorean identity and maybe called it secant squared of x minus 1? What will happen is that you would find that yourself essentially moving backwards, because having the monomial denominator is really a good place to start, and breaking that monomial into a binomial certainly is going to be counterproductive. And as the title of the example suggests, convert to sines and cosines, it seems like that's going to be our approach. So remember, a lot of times when you solve an integral, it's like a puzzle, and you might have to go through a little bit of trial and error before you find the approach that seems best. And as the statement suggests, converting to sines and cosines seems to be the answer here. We're going to convert the secant to 1 over cosine using the reciprocal identity. And of course, tangent squared would be sine squared over cosine squared. Now what we'll notice here is if we were to reciprocate the denominator and do a little bit of a canceling, we would end up with cosine to the first power over sine squared. Now, I did skip a step there, so to kind of talk you through it, picture this denominator flipped upside down and multiplied here on top. The cosine squared and the cosine will do just a bit of canceling, leaving you with 1 factor of cosine. Now, you look at this and you think, are we really any better off? And the answer to that question is, well, certainly we are a little bit better off, because we could manipulate this just a little bit more. In fact, there's more than one way to do this. We could manipulate this just a little bit, and we could maybe change that sine squared into being written as 1 over sine, and the cosine that stays up on top will also have a denominator of sine. So you can look back at it and say, okay, now is that equivalent? Well, of course it is. Top times top, bottom times bottom would give us cosine over sine squared. And where does this take us? Well, as you can see, 1 over sine is the same as the cosecant function, and cosine over sine is the cotangent function. And if you recall, that truly is one of your basic trigonometric integrals, in that you would get the negative cosecant of x.